Okay, I'm going to do a quick explanation on chapter 3. All of chapter 3 is going to be addition strategies. So I kind of wrote out a few problems. I have some manipulatives that I'll use, and that way you guys know kind of what we're doing during math each day. So this will be all of chapter 3, which is 11 lessons long. So in the very first lesson, we learned about adding in any order. So that means it's the commutative property of addition. So it doesn't matter which order the add-ins are in, you still get the same answer when adding. So for example, if I had 8 plus 9, I could switch my add-ins, which I also tell my students I can flip-flop them, which means it would be 9 plus 8, and I would still get the same answer of 17. On lesson 2, we have counting on. So when you're counting on, you start with the biggest number. So I had students circle the bigger number, and then they add on by drawing a picture. Your child knows that they can use circles or squares. We just draw quick pictures. So if I have 6, I would count on 2 more, which would be 6, 7, 8. So 2 plus 6 would be 8. In lesson 3, we're using doubles. Your students should be able to do these pretty quickly. It's 1 plus 1, 2 plus 2, 3 plus 3, 4 plus 4. We go all the way up to 10 plus 10. So when we first introduced it, we do a quick picture. So we draw towers is what we call them. 3 plus 3. So your child should be able to say 3, 4, 5, 6. But eventually, the idea is we want them to memorize these because it's going to make lesson 4 and all the other lessons easier. So lesson 4 would be doubles plus 1, which is why it's important that they know their doubles. We start with 6 plus 7, for example. I know that I could say a double for this would be, what I taught them to do would be to underline the bigger number, and we're going to circle the smaller number. So what that means is we can break apart the bigger number to make this into a double. So we know 6 is close to 7. So we could say 6 plus, and if we broke this one up, it would be 6 plus 1. We know 6 plus 6 is 12 plus 1 equals 13. So we use manipulatives. We have our Unifix cube. So I'll use 2 colors to show you 2 towers. So we would have 1, 2, 3, 4, 5, 6, 7. The other tower would be 6. 1, 2, 3, 4, 5, 6. So I show the students how they are close but not the same. If I broke this off, I would have to take the one that's taller so that my towers are the same length, and they would end up looking like this. So it'd be 6 plus 6 plus 1. So we know 6 plus 6 is 12, plus 1 more would be 13. And it's important that they also know that they need to write the answer on all blanks. Okay, so there is lessons 1 through 4. Let me grab 5 and 6. Okay, so 5 is knowing that you can use doubles plus 1 or you can use doubles minus 1. So if we're doing plus 1, we would break apart the 9. So it's just like we did in lesson 4. So you would say 8 plus 1, because 8 plus 1 is 9. If I have my manipulatives, I can make 2 towers, 1 of 8, 1 of 9, and take off 1 from the 9. So you would have 8 plus 1. We know 8 plus 8 is 16 plus 1. So 16 plus 1 would be 17. So 8 plus 9 is 17. If we're doing minus 1, we would actually start with the bigger number. So we would add 1 to the 8 to make it 9. So it would be 9 plus 9 minus 1 at the end. So 9 plus 9 is 18. If I got rid of 1, I would have 17. So 8 plus 9 is 17. It's pretty much the same thing. It's just knowing that they could use either doubles, but if they use the smaller double, they have to add 1. If they use the larger double, they have to subtract 1. Moving on to lesson 6. Lesson 6 is strategies for addition. We have multiple strategies that we can do. We can do counting on by 1, counting on by 2, counting on by 3. We could use our doubles plus 1, or our doubles minus 1. These are all of the strategies. Sorry, I had that one out of there. These are all the strategies that we could use when adding. So if I'm counting on by 1, for example, say I had 4 plus 1, I would say 4, 5. If I started with 5 and I add one more, it'd be 5, 6. Knowing that they don't have to say 1, 2, 3, 4, 5 plus 1 is 6. They should be able to start with a larger number and just go one more. Same thing with counting on 2. You would start with a larger number, but you would just go up 2. So say it's 5, 6, 7. If I start at 6, 7, 8. They're knowing that they can pick out the larger number to add. Same thing with counting on by 3s. If I started at 6 and I needed 3 more, I could say 6, 7, 8, 9. If I started with 7, I could count on 3 more by saying 7, 8, 9, 10. A common misconception that they make is when they're adding, they say the number again. So on 4 plus 1, they may say 4, and then they go 4. So they need to know that they have to go to the next number up. They can't repeat 4 twice. So it'd be 4, 5. Same thing with counting on by 2. If I said 5 and I add 2 more, sometimes they say 5, 6, which would be incorrect because the answer should be 7. So it's important that they start with the next number when they're adding. Doubles, 7 plus 7 is 14. This is a lesson that I already taught them. They should be memorizing them, especially by lesson 6. We also have our doubles plus 1. 5 plus 6 equals 11, which would be 5 plus 5 plus 1, which would be 5 plus 5 is 10, plus 1 is 11. Or we could do doubles minus 1, which would be 8 plus 7 equals 15 would be the example. So they could do 8 plus 8 minus 1. So 8 plus 8 is 16, minus 1 would give us 15. That's pretty much kind of like a review lesson, just for them to organize everything that we've learned about. Moving on to lesson 7. This is using a 10 frame to add 10. A lot of times we draw our 10 frames, but in class we will be using a magnetic board that is 10 frames, and then it'll have 2 colors, red and yellow, because that's the colors we usually go with. On your child's work, you might notice that they draw circles with an R in it. That means red. And if they draw a circle with a Y, it's the yellow, because we always refer to our 10 frames with the red and yellow counters. So this is a 10 frame. Oops, sorry. This is a 10 frame, and it's called a 10 frame because it has 10 squares inside of it that we'll be using to add. So on lesson 7, we're using a 10 frame to add 10. So I did the example of 10 plus 5. Your child's job would be to use 10 counters. So we'll start with red because that's the first number, and we want the first number is usually always starting with red in my class. So let me fill in 10. Okay, so they should have their 10 frame completely filled in. Now we have to show the second add-in, which is 5. So with that, I'm going to use yellow. So they're going to have 1, 2, 3, 4, 5. I call this the parking lot. This is just where the extra pieces go that don't have a spot on the 10 frame. So we know our number is going to be larger than 10. What's nice about this is if we have 10, we should be able to start with a larger number of 10 and count on 5 more. So they should be able to say 10, 11, 12, 13, 14, 15. So 10 plus 5 would be 15. On their work at home, what you could do is you could have them draw 10 circles for the first one. Okay? And they can color those in to show that they're red, or they can put an R inside of it to show that they're red. And then 5, which is the yellow one, would go underneath. So you would draw 5. So they would know 10, 11, 12, 13, 14, 15. Okay, on lesson 8, we're using the strategy make a 10 to find sums within 20. Sorry, my hand erased that a little. Okay, so I went ahead and kind of drew this one ahead of time. That way I wasn't spending time drawing a whole bunch of circles. But I'll use the 10 frame as well. So if I had the 10 frame, I would do 9 red, 1, 2, 3, 4, 5, 6, 7, 8, 9. And then down here, I would do the 5 yellow, 1, 2, 3, 4, 5. The goal of this is for the students to realize that the 10 frame is not full, and they need to make the 10 frame full. So what they could do is they could draw their 9 circles and then the 5 below. Over here, we're going to make it into a 10. So how many of these would we have to borrow to make this a 10? So they could easily take their magnetic pieces and move one up, and now they have a 10 frame. So now the addition problem becomes 10 plus 1, 2, 3, 4. So over here, the new addition problem would be 10 plus 4. So what they could do is they could draw this and put a line up to show that it moves up. So over here, they would now have 1, 2, 3,